So the last type of reaction that we're going to talk about, this is on page 3, right? Reaction number 5, combustion reactions. So a combustion reaction is a reaction that produces heat and light. So a combustion reaction is going to produce heat and light. We typically think of combustion reactions as fire because that produces heat, right, and light. We can see both of them. Now, something with this. Here's a way, if you're classifying chemical reactions, because of course, you know I'm going to ask you to classify chemical reactions. A way to tell that it's a combustion reaction is it always produces CO2 and H2O. These are always your products. So that means, right, remember your products are on the right of the arrow. The two things you're going to see to the right of the arrow are always CO2 and H2O, no matter what. It always produces CO2 and H2O. Something else with combustion reactions is that it needs oxygen to work. It needs oxygen to work. So that means, right, that oxygen is always a reactant. Right, oxygen is always a reactant. So in order for something to combust, it's reacting with oxygen. So when I light the ceiling on fire, I'm using the gas that's coming out of the gas jets, and I'm combining it with oxygen when I put the flame up to it. Now the other reactant, because remember this side of the arrow are the reactants. The other reactant is what we call a hydrocarbon. I'm going to put an X and a Y just to represent any subscripts. It could be a 1, it could be a 5, it could be a 10. But again, this is called a hydrocarbon. Hydro for hydrogen, carbon for carbon. Contains C and H. These are those balancing equations that we've been looking at that were always the tricky ones to balance because they had oxygen in 2 places on the products. And so this is always your general formula, your general equation for a combustion reaction. You have some sort of hydrocarbon plus oxygen gas, right? It's O2 because it's diatomic. Always, always, always make CO2 and H2O. So when you're identifying a combustion reaction, you can look for CO2 and H2O as products. Right? And it starts with a hydrocarbon plus oxygen. So what we're going to look at is we're going to look at the 2 balancing examples first. All right, looking at what are the reactants, what are the products, and then we'll get into the demo. So we take a look at these 2 examples. So this first one, C4H10, not that you don't need to know what these are called, I'm just telling you the names, but this is butane in a lighter. That's butane. So C4H10, when you, I don't know, do you turn on a lighter? When you light a lighter, I guess, you are combusting the butane. Now to finish off this butane reaction, so here's your hydrocarbon. You always need to add oxygen. You always add plus O2. And then your products for any combustion reaction. It does not matter what your C and your H are over here. Your products for a combustion reaction are always CO2 and H2O. Always CO2 and H2O. We could do the same thing for this. This is methane. This is the gas I'm going to light on fire in the lab. This is the gas that comes out of our gas jets. This is a hydrocarbon. Carbon and hydrogen together. If this is a combustion reaction, we will see plus O2. You need oxygen for a combustion reaction to occur. And it produces CO2 and H2O. So no matter what your hydrocarbon is, if it is combustion, it is always plus O2 yields CO2 and H2O. And then I get the question, okay, well, but there's different numbers of carbons and hydrogens and oxygens. That's where balancing comes in. That's where adding our coefficients come in. So that's where we put those coefficients in front to actually balance the entire reaction. A tip for balancing. Right, so tip for balancing. Because remember, we're going to continue to balance equations. Put those coefficients in front. Right, start with a 2 in front of the hydrocarbon. So this is where last week when we were talking about balancing and I said combustion reactions, I kept talking about combustion reactions. That's these. To make your life easier, start as soon as you realize that this is combustion, start by putting a 2 in front. Start by putting a 2 in front and then balance. Right? You balance it C, then H, then O. So remember the 2 goes to both things. So I have 2 times 4. I have 8 carbons here. Right here I only have 1. Right? This isn't in parentheses. This 2 doesn't go to everything. There's only 1 carbon here. So I'm going to put an 8. This 2 also goes to hydrogen. 2 times 10 is 20 hydrogens. Over here I only have 2. So I'm going to put a 10 in front. Now I have 20 hydrogens on the product side. Now when you're looking at oxygens, remember I have oxygens in 2 places. So we have to add up all of our oxygens on the product side. 8 times 2 is 16. 10 times 1 is 10. So there are 26 oxygens on the right-hand side. Here there's only 2. What can I multiply by 2 to get to 26? 13. So my coefficients are 2, 13, 8, and 10. Notice how I can't reduce those, right? 13 isn't divisible by 2. And so you can go through and balance those as well. Combustion reactions are probably the easiest when it comes to predicting products because it's the same every single time. It's always CO2 and H2O. Get your cameras ready, this will be a good one.
Oh.
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 Oh no!
Oh no!
Oh no!
Feel the heat burn.
It's really hot.
Hurry, swim!
Hurry,
Swim!
swim!
There's one on the ceiling.
Where?
It's
Right
here! It's by the lights.
Right.
It's falling.
Turn right where all the fire is.
No! Just get this one. Get the next one.
Ooh.
Get the sounds from
Oh. She just said.
Swan, light it on
She said that she burnt her hand for one.
Let's do it again.
I'll
For the
For
content, though. For the content.
This is literally
You suck.